All right, let's dive into some more domain and range problems. So here we're starting with two graphs, and I want to know the domain and range of each of them. We're going to write a set. First question is it just plain all real numbers? Does this graph go on forever in both directions? So, does this graph go forever in the x direction? Yeah, if we pick an x down here, we could go up and find out the y output. But does it go forever this way? And the answer is no. It stops right here. It does not go beyond 8. So how can we describe this? The set of all x is such that x is less than or equal to, solid dot, 8. So that's our domain, side to side, inputs. Let's look at outputs. Does this graph go up forever? You bet. Does it go down forever? No, it doesn't go down forever. The lowest that this graph ever gets is -2. But it's everything above that. So we say that range is the set of all y's such that y is greater than or equal to -2. The second one. Pause the video and write down what you think the domain and range are. You should have said the domain is the set of all x's such that x is an element of the real numbers. This graph goes forever to the left and forever to the right. Our range. The set of y's such that y is greater than or equal to -1. -1 is the lowest that this graph gets, and it's everything above that. Now we're going to start with some functions. We're going to start with this function notation, and we're going to determine the domain and range for these. So, what can't x be here? Well, we know that x minus 5 has to be greater than or equal to 0 to square root. That stuff underneath can't be less than 0. So let's figure out what x can be. Let's add 5. X is greater than or equal to 5. There's my domain. Any x value greater than or equal to 5 will work for this. And then, okay, square root. What kind of outputs do we get from this? We always get a positive output. Then we get 0. If x was 5, 5 minus 5 is 0, square root of 5 is 0. Our range is the set of y's such that y is greater than or equal to 0. Now, you might be thinking, yeah, that's good when you explain it, but I can't do that. I need a picture. Okay, well, let's go to our graph. What were we trying to graph? We were trying to look at the square root of x minus 5. There it is. So, can you see from this where the domain and range are? It's all x is greater than or equal to 5, and it's all y is greater than or equal to 0. So if you need to graph something to determine its domain and range, go for it. And now we got two more. F of x equals 1 over x minus 5. Now, 1 over x minus 5, that's a rational function. That's something over x. We know the denominator of these types of things can never be 0. So x minus 5 cannot be 0. So what can't x be? X cannot be 5. So our domain, the set of all x's, such that x is not 5. The range, and sometimes this is harder, If you're not sure, again, go to the calculator. It's not a bad place to go. 1 divided by parentheses x minus 5. So there we go. What's going on right here? That's where x equals 5. That's a vertical asymptote, ladies and gentlemen. That's where the graph cannot be for x. We have this vertical asymptote here. Notice on the y-axis, no matter how big x gets, this never becomes 0. 1 over 5 billion minus 5. This is really teeny tiny decimal, teeny tiny fraction. Same thing going out the negative way. X equals negative 5 billion minus 5. 1 over that really teeny tiny number. So our range, our output, is the set of y's such that y does not equal 0. And notice C. C is a combination of these two ways. So hopefully you can see what's going to happen. The domain for this. If we didn't have the square root, we know it's this. With the square root, we know that it can't equal 5. So this one's saying that everything greater than or equal to 5. This one's saying no 5. The domain will be the set of x's such that x is greater than 5. We don't include 5 in this one because we can't have 0 in the denominator. The range. Similar idea. This one says that it's a set of all y's such that y is greater than or equal to 0. 0 and bigger. But then this one says as soon as it's going in the bottom, we can't have 0 there. So our range is a set of all y's such that y is greater than 0. No or equal to 1. Again, if you have trouble with this, look at the graph. Plug it in. Pay attention to the table. See where the errors are in the y equals column or the f1x column of your table. It can be a great help if you can't visualize this algebraically.